For our first partial project of calculus, they asked us if we could use two examples of the practice study guide they gave us and explain it to someone like they haven't had the class of calculus yet. So we chose two problems from the lab and we're going to show you how to do them step by step.
For one of our examples, we're going to use problem number 10, which consists of limit of 2x cubed plus 54 over 3x plus 9 when x approaches -3. The first step is to substitute x. You will substitute x with the constant or the number to which x approaches to, in this case -3. So you will have 2 times -3 cubed plus 54 over 3 times -3 plus 9. Your answer will be 0 over 0. Since it's divided by 0 and it's not a finite number, your problem is problematic and you have to find your limits. Remember to always write limits or LIM and on the bottom when x approaches and your constant or your number, because if not you're doing only an equation and it's not really finding a limit. The next step is to factor. What we did in this case is taking out the common factor. For the numerator, we took out the 2, so we got x cubed plus 27, and on denominator, we took out the 3, which left us x plus 3. Again, write limit when x approaches -3. Now we're going to simplify further. With our x cubed plus 27, we're going to apply to it the sum of cubes. So our answer for that part will be 2 times x plus 3 times x squared minus 3x plus 9. On the bottom, we're going to leave it the same as it is, which is 3x plus 3. And we're going to cancel out both x plus 3's, one from the numerator and the other from the denominator. Now we're going to rewrite our equation without the terms we already cancel out. So it's 2x squared minus 3x plus 9 over 3. Now that we have our equation, we substitute our -3 inside it to find our limit. So it will be limit of 2 times -3 squared minus 3 times -3 plus 9 over 3. And their answer will be 18. In order to be absolutely and mathematically correct, remember to write your complete answer, which is limit of 2x cubed plus 54 over 3x plus 9 when x approaches -3 equals 18. For our second demonstration, we're going to use problem 54, which is f of x equals 2x cubed minus x squared plus 5x plus 7. In this problem, we have to find the derivative by using the definition. Remember that when we say find the derivative by definition, we mean to use the formula, which is f prime of x equals the limit of f times parentheses x plus h close parentheses minus fx over h. All this when h approaches 0. First, we're going to focus on the f times parentheses x plus h. And now we're going to take all that away and instead put our function that was given to us earlier, our problem. But now, instead of being 2x cubed, it's going to be 2x plus h in the parentheses cubed. So basically what we're doing is replacing all our x's for parentheses x plus h. Remember that since we're working with limits, so always put limits, and in this case, when h approaches 0. And now we write 2 parentheses x plus h cubed minus parentheses x plus h squared plus 5 parentheses x plus h plus 7. All of that over h. Now for the next step, you can choose to simplify what we just did first, which would be multiplying our numbers or using the rules we mentioned earlier, which are the sum of cubes. In this case, we have 2 times the parentheses of x cubed plus 3x squared h plus 3xh squared plus h squared. Close parentheses minus open parentheses x squared plus 2xh plus h squared. Close parentheses plus 5x plus 5h plus 7 minus open parentheses 2x cubed minus x squared plus 5x plus 7 close parentheses. All of that again divided by h. Now you're going to multiply certain parentheses that have a number or a sign outside of them by that number or sign. For example, in the first parenthesis we have a 2 outside, so we multiply all that times 2. The second parenthesis has a negative sign outside, so we multiply all the numbers and excess inside times that negative number. For the last parenthesis, that's in the last section of the equation, is all of that again times a negative number. Remember that all of that is over h. Remember to cancel out the terms that can be canceled out, for example, the 7 and a negative 7, the 2x cubed with a negative 2x cubed, and all that, in order to be able to have the correct answer at the end. After canceling out and adding all the terms that can be added and cancelled, we have as an answer 6x squared h plus 6xh squared plus 2h cubed minus 2xh minus h squared plus 5h. All of that again over h. Now we are taking out the common factor again, so we have the h outside, which is our common factor, and we have inside the parentheses 6x squared plus 6xh plus 2h squared minus 2x minus h plus 5, and divided all of that by h. Now we can cancel out both h's, the one on top in the numerator and the one on the bottom in the denominator. As an answer to that, we have 6x squared plus 6xh plus 2h squared minus 2x plus h plus 5. The next step is to substitute all remaining h's with a 0, so they will automatically cancel out, and they will leave us with an answer of 6x squared minus 2x plus 5. And that's your answer. Of course, you have to write limit of 6x squared minus 2x plus 5 when h approaches 0, and that's your final answer.